This video is about factoring. We're going to do an introduction to factoring. So our objective is to factor some basic patterns of our either binomials or trinomials for primarily quadratics. So first of all, in looking at this, we want to talk about what factoring is. Factoring is undoing multiplication. And I'll put undoing in quotes, but when we multiply together, we usually get, for instance, these trinomials and binomials. We want to take that final result after you multiply them and undo it to see what the original factors were. So that's what we want to do with the factoring. There's a couple rules we need to follow. The first rule, rule number one, is to factor out the greatest common factor. It's often referred to as the GCF. Second, you want to look for patterns. And what I want to do today is talk about two of those patterns. The pattern of where we have binomials and a pattern where we have trinomials with a leading coefficient of 1. So when we look at this example here for factoring, you look to factor out a common factor, the greatest common factor. What do 10 and 70 have in common? Well, they have a 10. And what do x squared and x have in common? They have an x. So if we distribute them out, so undo the multiplication by taking it out of the parentheses, what we're left with is, if we take 10x out of 10x squared, you're left with one factor of x, because 10x times x is 10x squared. Undone. Now on this one, when you take a 10 out of the 70, you're left with a 7, and we took the x out, distributed it out, so you only have a 7 left. So 10x times the minus 7 would be the minus 70x. So the factoring will undo it, bring that common factor out, so it looks like what we often have is the problem that we multiply and distribute through to get the problem that we're working on. Okay, a couple terms that we want to refer to. A binomial is where you have several terms when you limit it at 2, so you only have 2 terms. So 2 terms. So our polynomials, poly meaning many, so the many terms are limited to just 2, then that's a binomial, so the key is the bi. So you can make sense what a trinomial is that you have 3 terms. So we're going to look at those in our factoring. Later we'll look at 4 terms and oftentimes have patterns for those. But to start with, notice that this is a difference of 2 squares pattern. There's 2 terms here, so this is a binomial. So when you see a binomial, and the key is that you see that there's a difference, there's a subtraction in between them, and these two are perfect squares. It's this one squared minus that one squared. Then it's going to factor into m minus n times m plus n. The reason why that works, again, this is undoing it so that you undo the multiplication. If I were to multiply to show that this equals this, notice it would be m times m is m squared. M times plus n is plus mn. Negative n times m is negative mn. I'll just write the m first because of commuting. And then negative n times positive n is minus n squared. You look at these middle terms, they get rid of each other, and you end up with just the 2 terms, which are a difference of squares. So that's why that pattern is it's very convenient to know, because if you see 2 terms and a minus in between and they're perfect squares, it quickly factors into this pattern of m minus n, m plus n. Let's look at 2 examples here. This one here, we got, again, we'll draw our 2 parentheses. We've got 2 terms, a minus in between. This is a perfect square, that's a perfect square. So x, if you take the square root of it, you're going to get x and x. And then the 36, its square root is 6. And then you just put a minus and a plus. And if you were to distribute this through, double distribute through, you get x squared plus 6x minus 6x. Middle terms are gone, minus 36. All right, now this next one, it looks like difference of two squares, and it is, but don't forget, you've got to look for that GCF first. That's your first rule, is to look for GCF. And both of these two have a 4 that goes into it. So you got to take out the 4 first. So 4 comes out, and you're left with 25x squared minus 9. This continues to be a perfect square, so we can go ahead and factor that into two parentheses now. So undo the double distributing. So 25x squared, we're going to factor into 5x and 5x. And then the minus 9 will make a 3 and a 3, make one a minus and one a plus. By the way, if the minus and plus are switched, that's okay, but one has to be a minus, one has to be a plus. So those are our final answers for how these factor, undoing the multiplication to get it in fully factored form. All right, yeah, let's go ahead. Make sure, by the way, we did take the GCF out first. If you had done this as the difference of two squares with a 10x and a 6, you wouldn't have had it fully factored. You still would have GCFs to take out, and the GCFs do have to come out. All right, let's look at trinomials. Okay, so a trinomial, remember, has a 3 terms, so 3 terms here. And so when we have a leading coefficient of 1, meaning that there's a 1 in front of the x squared, that's critical. So notice if you have a leading coefficient of 1, the pattern we're looking for two numbers that multiply to get C, the last number, and they add to get this B. Okay, so looking for two numbers that add to get the B and multiply to get the C. All right, so let's look at this first one here. By the way, it's helpful when you do this, maybe to write the first of all, look for GCF. There is no greatest common factor, but then write out 2 parentheses so that we know what we're working with. And because it's x squared, we're gonna write x and x. Now we're looking for two numbers that multiply together, give you 10, add together, give you -7. Well, the things that multiply to get 10 are, for instance, 10 and 1, 5 and 2, or you could have -10 and -1, -5 and -2, -5 and -2, add together to get that -7. That's my factorization then. That's the secret for doing this, because if I were to distribute it back through, which this is done, this is the answer, okay? But if you're checking it, x squared minus 2x minus 5x is minus 7x, and then plus 10, -5 times -2. All right, now this one's being sneaky a little bit. Number 2, you have to take out the greatest common factor first. So take out the 2, you're left with x squared plus 11x plus 10. Now we're looking for two numbers, remember, that are multiplying to get that 10. Well, one combination is 10 and 1. So we're going to go ahead and write out our parentheses in this case. X and x, 10 times 1 is equal to 10. 10 plus 1 is 11. So I make it plus 10 and plus 1. And that's my final factorization of number 2. I changed variables on this one just so that we're aware that it doesn't always have to be x that we're factoring. So for this one, I'm looking to factor, and so there's no greatest common factor in each one of these, so you want to make sure you go ahead and look for that first. I'm going to put a and a here, and then what I want to do is look for two numbers that multiply together, give me -54, add together, give me -3. Well, -54 has many different factors of it, but I do know that 54 is 9 times 6. If I make one of them negative, it's -9 times +6. We'll multiply to get -54, and negative 9 plus positive 6. So let's do this. Negative 9 times 6 is negative 54, and negative 9 plus 6 is equal to negative 3. That's what I'm looking for in this combination. So I'm going to use negative 9 and positive 6, and that's my factorization of it. So looking for that, two numbers that multiply to get the last one, add to get this one. All right, now looking at this one, we do have a GCF on this that includes an x. So you have a 10 in each of them, you have an x in each of them. So let's take out the 10 and the x. You're left with, when you take out the 10x, x squared plus 2x minus 35. Now, notice once I factored that out, I now have a leading coefficient of 1. So I can use this pattern when there's a 1 in front. I couldn't when there was a 10 in front. Just like on this one, when I took out the 2, it now has a 1 in front, so I can use the pattern. So I'm going to look to see what my two parentheses could be. X and x. And now I want to look for two numbers that multiply to get negative 35 and add together to give you 2. Well, that would be negative 7, or positive 7, and negative 5. Positive 7, 7 times negative 5 is equal to negative 35, and 7 plus negative 5, their sum is equal to positive 2, so that gets me those two numbers. If you were to distribute this out, double distribute, you would get this answer. So this is my final factorization of that, and we're just doing a check. So factoring is about making sure you look for patterns, but follow the rules. Take out your GCF first, and then undo the multiplication by looking for the patterns. We've done 2 of them here, the difference of squares, and also the pattern where you have a trinomial with a leading coefficient of 1. Use those patterns to undo the multiplication and come up with your final factorization.